Concrete is one of the most widely used materials in the construction industry.
However, ceramic tile waste contributes significantly to environmental pollution and landfill accumulation.
Due to its resistance to decomposition, discarded tiles remain in landfills for long periods.
Therefore, this project explores the use of recycled ceramic tiles as partial replacement for coarse aggregate in concrete.
This project aims to investigate the potential of recycled ceramic tile waste as a partial replacement for coarse aggregate in concrete production. In this study, concrete mixes containing 5% and 10% tile replacement were prepared and tested. The compressive strength performance of each mix was then compared after 28 days of curing. Additionally, this project promotes sustainable construction practices by reducing construction waste and encouraging material recycling.
The rapid growth of construction activities has increased the amount of ceramic tile waste produced worldwide. When disposed in landfills, ceramic tiles do not decompose naturally. At the same time, natural coarse aggregates are continuously extracted for concrete production. This creates the need for sustainable alternative materials in modern construction.
The compressive strength test was conducted after 28 days of curing to evaluate the performance of the concrete specimens. The results indicate that the 10% replacement performed better compared to the 5% replacement. This improvement may be influenced by the rough texture and angular shape of crushed ceramic tiles, which can contribute to better interlocking within the concrete matrix. Therefore, recycled ceramic tile aggregates demonstrate strong potential as a sustainable alternative material in concrete production.
This section outlines the methodology adopted to investigate the use of ceramic tile waste as a partial replacement for coarse aggregates in concrete. The materials used in this experiment consist of sand, aggregates, water, cement, and of course crushed tile waste. 3 concrete mixes were prepared. The control sample contained 0% tile replacement, while batch 1 and batch 2 contained 5% and 10% crushed tile replacement respectively. Compacting is using a rod to tamp the concrete, removing trapped air and making it dense and strong. Leveling surface is a screed or straight edge is used to spread and smooth the surface until it's flat and even. Curing is the process of the concrete is kept moist for 28 days to allow proper hydration, increase strength, and reduce cracking. Compression test is where the concrete cubes are cured and then tested in a compression machine. Load is applied until failure to determine its compressive strength.
Now, to bring our entire presentation to a close, let's look at the final conclusions of our study. To put our work into perspective, I want you to imagine the sheer volume of ceramic waste produced globally every single year. Unlike many materials, once a ceramic tile is fired in a kiln, it changes forever. It cannot be turned back into clay, and it won't decompose in our lifetime. In fact, these tiles sit in landfills for thousands of years. Our group looked at these mountains of broken tiles and saw potential building blocks for the future. In conclusion, our research has successfully proven that recycled ceramic tile waste is not just waste. It is a high-performing, sustainable alternative in concrete production. Through rigorous aggregate substitution, we explored how this eco-friendly material can effectively preserve structural integrity while offering a green alternative for the construction industry. Through comprehensive cube testing and data analysis, we identified a critical, sweet spot in the mix. Among all our tested samples, it was the 10% replacement level that achieved the most superior compressive strength performance. At this precise percentage, the recycled tiles integrate perfectly with the cement paste, maintaining structural safety while maximizing sustainability. Ultimately, this study is about more than just concrete cubes. It's about a paradigm shift in how we approach civil engineering. By adopting this 10% replacement standard, we can divert millions of tons of ceramic waste from our landfills and significantly reduce the carbon footprint of the construction industry. We are proving that through innovative engineering, we can build a world that is not only structurally sound, but also environmentally responsible. This is the future of sustainable construction. Thank you very much for your time and attention.